everyone. So on the Lyft ride over here, a driver named Paolo asked me, why do you think people dehumanize women so much? How did they get to that point? So this is a very interesting question. I had thought about a related question to start off with, and that is, why should we care about harassment? So a 13-year-old girl named Tanya earns A's and B's in school, and then drops to D's and F's because she's harassed physically and verbally every day in school by other students. So her opportunities to learn and contribute are derailed, and in addition to this, she begins to wonder whether she should even live anymore. Now, some people might say, who cares? Like, I still can't identify with this. This just doesn't relate to me. So let's try some examples that might relate. Given how rampant harassment is, and how seemingly deeply personal it also is, it's possible that some of us might have someone we care about who has been harassed, but we don't know it. In this case, Ray found out that her mom was harassed before through her mom's Me Too hashtag. So some of you might be parents, and the person you might most care about is your child. In this case, Jessica wakes up and reads a violent, gender-based threat against her 5-year-old daughter. Conversely, it's possible that someone close to us is actually a harasser. How would we deal with that? In this case here, a dad refuses to empathize with the woman who was assaulted by his son. So these are actually examples that represent myriad examples of such gender inequality. Many, including the United Nations, believes that the human rights of women are the most widely ignored in the world. And Shruti van Hemmen, Apekshit Sharma, and myself narrowed the scope to a subproblem: online gender harassment. This might have turned off. Oh, user error then. So in part of the world, nearly 1 of 2 women is harassed online. And if under age 30, 3 of 4 women is harassed online. Women in politics face similar rates of online harassment, and a large percent believe that this is to curtail their offline attempts at achievement here, such as running for office. So these types of cases really limit the essentially voices, equal opportunities, and treatment, and really cut across and affect within and between races and ethnicities, families, countries, and so on. To learn further and deepen our understanding, we actually met with strangers, women who have been harassed online on Twitter, to actually understand from them what essentially they define as online gender harassment, what they've experienced, and what they view as potential solutions in this area. And what we found from numerous women is that they actually anonymize their gender in their usernames. They have reduced their engagement on Twitter and other social media, and they actually have low confidence in Twitter anti-harassment tools. So based on their feedback, we iterated and attempted 2 data science products. I'm not very good at this. I jumped way too far. Something's wrong. Here. Ay. Okay. Actually, this was the screen. All right. So the first product was aimed at users who retweet or reply with gender harassment. And so these are Twitter bots that automatically detect and respond to these users. So the second product is a Chrome extension beta version for women who are harassed and want to block some of that harassment online. So this will automatically detect and block at least some of the tweets. So for the rest of this presentation, we'll walk through some of the work that went into this, and we'll start with the data collection and artificial intelligence. So the initial obstacle is that of 10,000 tweets, there's actually about less than 50 gender harassing tweets. So this suggests that we would have to manually review 300,000 tweets just to get 3,000 gender harassment tweets. This is not feasible during Capstone. It's not even recommended at a company. So in order to get around this, the solution was active learning. My company actually uses active learning currently. So step one, we collect about 1,000 gender harassment tweets. No, I should say 1,000 overall tweets, 500 gender harassment, 500 not gender harassment. Immediately, we train a baseline logistic regression model in step two. And then we move to step three and throw in new tweets that the model hasn't seen yet. Okay, so we've presented to different stakeholders. Sometimes we find that people do not even want to see offensive or violent tweets. So to be careful here, I've actually graded out. So this is a case of one user interface we used. We would have the tweets here, and then the probability of gender harassment in the second rightmost column over there. And you can imagine if you're a company and you're going to send out, say, tweets or data to be labeled for you at scale, you actually do not want to send out tweets or data that you know your model is already confident on. Like if the probability is near 0 or near 100, there's no need to spend the money on that. Instead, what you want to do is you want to send tweets that the model is currently confused with. And so what we did here was any tweets that are between 50% likelihood and 90% likelihood of gender harassment, we're disproportionately sampling and labeling these. So we don't have to go through all the other tweets. And then, of course, we would label within IPython Notebook, 1, of course, for harassment, 0 if not harassment. And then we would immediately feed this back in to the model and retrain, and then the new set of tweets would come in. So we'd iterate over this process over and over. Okay, so overall we had 18.8 thousand tweets, 3.3 thousand harassment tweets, and we collected this through our own team self-labeling. We hired Mechanical Turk women workers, and then we identified an existing Proudflower data set. And then we randomly assigned these tweets to our train set, validation set, and test data set. Okay, so now we get into the categories of machine learning models that we were using. So gradient boosting decision trees, feed-forward neural networks, and logistic regression. And then in the category of feed-forward neural network, we break it down into subcategories, embedding layer and no embedding layer. So in very simplified terms, for those not familiar, an embedding layer is essentially, in this case, taking a tweet, not the word, and placing it in n-dimensional space. And if another tweet is semantically similar to that, then it is going to be very near that in the n-dimensional space. So let's focus actually on the feed-forward neural network, no embedding layer. We're going to run this model 100 times. And each time, we're not going to run a grid search, which is very computationally intensive. Instead, we're going to run an efficient random search across 10 hyperparameters within our defined ranges. So let's actually take a look at what this appears to be. So this is a snippet of code that we have. Iteration 1, we come in to run this model. We're going to run a random search on the number of hidden layers for this neural network. We're going to select a random integer between 1 and 4. That's an example of a random search here. Now the dropout rate is another one we can go over. Essentially, at each layer, you can drop out anywhere from 5 to 95%, in this case, of your neurons. You don't want to calculate weights for them, and this can reduce your variance and essentially reduce your overfitting. And then we do it for these other hyperparameters as well. Let me go back here. Okay, so we actually do this 100 models per category, subcategory models. And then what we're most interested in is sampling the best model, or best, actually I should say, best combination of models, not the best model. And the reason is that if you take one model and it's wrong, you're wrong. But if you have 8 models, for example, 2 are wrong, 6 are right, you actually are right. And so models can compensate for each other and give you less variance, less overfitting, better results. In our case, we ended up with 5 gradient boosting decision trees, 2 feed-forward neural networks, and 1 logistic regression. I wanted to go over this, but I'm not sure about the timing. Maybe if there's interest later. So, okay, during week 4, our entire team, we agreed that if we're going to build this out to be defensible in our product, we need our precision to be around 80%. So for those who haven't studied precision yet, in this case, it's of all the gender harassment tweets that we predict to be harassment, what percentage are we accurate on? So in this case, we're right 78% of the time with a very low standard error of 0.5. Now, recall is another metric that we're very interested in. So this is of all the tweets that are gender harassment that our classifier comes in contact with, what percent can it actually capture? And in this case, it was 34.5%, which we were satisfied with. This actually beat what we were initially trying for. And we ran these numbers by, in general terms, not technical terms, with some of our women interviewees. And they actually were okay with this. They felt that this was a good start and in line with the concept of mitigation. So you can see we ran a couple other ensembles here that we wanted to graph out. We did reach 80% precision on the far right, but felt the combination of precision and recall here was best. So that's what we have in production with our products. So we extrapolated and calculated that if there are 500 tweets sent per day, and we were to run our product on that, our models on that, we could capture or detect about 1 million plus tweets per week. And the one caveat is that we would also detect incorrectly about 300,000 tweets incorrect. So to be transparent, wanted to throw that out there. Now, after we have our AI ensemble, we bake this into our Storm pipeline. So streaming the tweets, filtering the tweets, classifying as harassment or not harassment, and then replying. Okay, so a week and a half after graduation, we met with a team at Google that focuses on anti-harassment and toxic language. And one person who was particularly interested in our work was the chief scientist of Jigsaw. His name is Lucas Dixon. So we actually formed a 7-month partnership with him informally, and he was very interested in this next work that we'll show you. This is a field experiment that is more robust than what we did during Capstone. And in addition, we later published on this study. So in this case, we're going to have 4 profiles, all linked to our Storm pipeline. And let's just focus on treatment bot 1 and 2 to start off. The profile images are the same, usernames are similar. The primary difference is the reply. So Alex Hughes, who is an instructor of the field experiments, he actually sent us a paper on what's called injunctive versus descriptive norms. So that's essentially what we're trying to test here. An injunctive norm is essentially what is behavior typically unaccepted. Descriptive norm is behavior typically lived. And research shows that descriptive norms typically work better. Now, treatment bots 3 and 4 differ from 1 and 2 in that they have bot specifically in the username, and in addition, we call out this is a bot in the summary. And the reason why we want to do this is we want to see if treatment bot 1 and 3, for example, a bot disguised as a human versus a bot called out as a bot actually have a different impact on people who are harassing. So a very important concept that we used here is 2 stages of randomization. So the first stage is that we found a lot of users who, based on their history, were likely to harass during the study period. And then what we did was randomly assign them to each of these 4 profiles. Once we activate for them to respond to these users, once it detects a user has sent a gender harassing tweet, it randomizes again, but it randomizes into either treatment or control. So our hypothesis is that the percent of users misogynistic tweets in the treatment groups will be lower than in the control groups if we send these replies. So let's take a look at some results. First, the timeline. July 27th, we start the pre-treatment. We're analyzing users for a couple weeks. We activate the treatment bots to reply to harassers. Again, this is when the second stage randomization occurs, where once the harassment is detected, it sends the user into either treatment or control. And then we analyze these users for another 2 to 3 weeks. So the results here actually show there's no statistically significant difference, whether you're in the control group or the treatment groups. We found similar findings with treatment bots 3 and 4 versus the control group. I just wanted to show this quickly. You can see that the 95% confidence intervals are overlapping each other. What we did here was compute non-regression weighted means, and then we also computed weighted standard errors through bootstrapping. So here is a different part in which we actually started with what's called difference in differences. And then we were talking with Professor David Riley, and he actually suggested we go with weighted least squares regression. And one reason is that your percent of offensive tweets in the pre-treatment period in a difference in difference model would be fixed at 1.0. So weighted least squares is more functional in that it can allow it to vary. The second part is that we weighted users based on the number of tweets that they sent through the entire study. And it's easier to weight through weighted least squares. Lastly, our R squared and adjusted R squared jumped noticeably. Okay, so though we saw no impact, at least in terms of statistical significance, we published with Lucas Dixon cited. His head of communications also reviewed our work. And in this paper or article, blog post series, we actually cite and emphasize that social media platforms such as Twitter, if they can publicly quantify whether there's impact or no impact, that would actually increase urgency, transparency, and better solutions. So this was actually shared with Twitter from Lucas on February 1st. Now, we're not going to claim any cause effect here, but we noticed that 1 month later, Twitter releases a request for proposals asking users externally, anyone, to come up with health metrics that can allow them to evaluate their platform better. Interestingly, they also reached out to us around this time. Okay, so now let's go into the browser extension quickly. Okay, so here we built, this is not the one that I want. Okay, we built 3 features into this browser extension. The first is in the upper right-hand corner, and it's a threshold between 0.0 and 1.0 with the default 0.70. So this means that any tweets that are 70% likely or higher to be gender harassment are blocked. But what we found is that women interviewees, some of them were interested in customizing this. They actually want to input their own value. Some were interested to only block the most extreme tweets, so they would want to set it at 0.9. Others were interested to block a greater share of tweets, and therefore were interested to set it at 0.6. Okay, for the second and third features, one is that even if we block a tweet, the user can show it to see what it is. So let's actually let this run a little bit.
Or unhide it.
Oops.
The third user feature is this button here that you see in red. You can select or deselect it. For example, if you don't think that this tweet is gender harassment, you can deselect it. And then you can refresh the web page. The Chrome extension will remember your preference, and it will no longer hide that tweet. In contrast, assume that you think that this is gender harassment and that the tweet was never blocked to begin with. Similar to how users flag spam in Gmail, you can flag the tweet as gender harassment by selecting the button, and it turns red. You can then refresh the web page. The Chrome extension remembers your preference, and then it blocks as possibly offensive content. For more information on the product and motivation.
Okay, so I can either thank myself or get upset at myself for interrupting myself. Okay, so let's see. How are we on time?
Probably another
5 minutes.
and then we'll go to questions.
Okay, so let's see. So I wanted to end on this. This is a motivating question that actually led me to the MIDS program and stuck with me even at the start of Capstone. And what I did at the start of Capstone was look back at all the Capstone projects in 2016 to learn. And I saw amazing projects which inspired our work, even though in a different domain. Interestingly though, none were in the domain of how data science can improve interpersonal relations, at least from what I could tell. And so I really think if data science is making an impact, for example, in physical health, predicting, for example, cancer detection, why can't we do that in the realm of dehumanization? Because this is such a huge issue. Some could argue, and I believe, that actually the greatest issue in our world is that we dehumanize each other. The greatest pain is preventable, but we inflict it on each other. And so obviously, whether in Capstone or outside of Capstone, you want to choose what you're most passionate about, because that will allow you to pursue the techniques you're most interested in, stay up late, put in the extra effort. But if any of you find that you actually have that deep affinity for this particular domain, then this domain needs you. It needs your talent, your passion, to try to address this vicious cycle of dehumanization. Thank you.
Derek, thank you very much. Important work, and as you say, the Capstone project, the winning Capstone project of last year. We've got time for a few thoughts and questions on this, if anyone would like to kick us off. Let's take one there, and then we'll come here. Thank you.
Thanks, it's really interesting stuff. I assume you're using the browser extension to get new data, to train new sets, to refine the algorithm a little bit. I guess my question is, what's next? Where are you taking this now that, based on what you've learned?
Yeah, so great question. I think our team is worn out. Honestly, I don't think, I think this requires to go to the next level, almost full-time work. And our team is, after 2 years of staying up late a lot, trying to balance this for almost another year. I think we're toward the end. I think it's going to be marketing at this point to see what the interest level is, because we haven't really focused on that yet. We do want to dive in a little bit with Twitter and maybe serve more as consultants rather than leading the work ourselves.
Okay. We have a question down here, please. So we'll take two from this side. In here first, please. Thank you.
Thanks for your work. I was curious if you thought about measuring. So even though the bot didn't statistically, reduce the tweets, did you think about measuring the impact to the targets or the impact to people to women who viewed the tweets? So even if it doesn't stop the tweets, does it make people feel more safe to see that there's some opposition? I'm curious if you thought about that.
We did not. That's a great idea. One of the engineers at Google Jigsaw proposed something like that. She was very interested in that. But our pipeline was not really set up to do that. So in Capstone, you have like 12 weeks together as a team. We built a really good pipeline, but for Capstone, once we got into this larger full experiment, we actually could see that we have to make some adjustments. or it's going to be a lot of post-processing work. So in this case, we had to tell them, with our full-time jobs, we can't pull that off.
Okay. Can we take the mic 2 rows back there? Thank you. Oh. Sure. Any other question? Okay, thank you.
One interesting point, which I won't show because there's a lot of offensive language in it. We did, however, publish some responses of people who received the harassing, like the tweet that said stop harassing. And we could tell that we kind of got into some concerns on ethics and whether or not we actually should have done the study, because some people were pretty upset on this being sent out. They can tell it's a bot. And in addition to that, as mentioned, we're not right 100% of the time. So it's actually not fair to a user to say you're harassing when they're actually not.
Okay. Lady in the 3rd row there. You can, thank you.
Hi, thanks for the great presentation. I thought it was really interesting what you were talking about, or the comparison between the different bots, one appearing as a bot and one was appearing as a male. I was wondering if you were to go, in the end, though it didn't turn out that there was much difference between them, if you were to go back and have the resources and stuff to try again, what other bots would you try? I thought it was interesting that it was a male, like what would a female look like, or an organization maybe?
Yeah, great question. So since we had limited time, we tried to choose what we thought would have the best effect. And Kevin Munger at NYU ran an experiment that was not automated like ours. His was kind of manual, but it actually showed that a white male bot was actually decreasing racist tweets, whereas other bots had less effect. So we said if we had one shot at this in Capstone, let's go white male. But I think there's all types of things we could do. We were actually interested to pose as if we were Twitter and had the authority to suspend. But then we said, ethically, we don't think so. No.
Okay. Do you still pass the microphone back? Yes, thank you.
So have you thought about making this open source since you don't have the will to take it forward, sounds like?
Yeah, interesting question. So, so we presented tweets to, we actually went into Google in May of last year, and we showed their model versus our model side by side on a bunch of tweets. So there's this kind of different, they're detecting toxicity, we're detecting harassment. But we would kind of show where theirs is off, where ours was right, and vice versa. And Lucas was interested for us, can you open source this? And we thought about it, and I think right now the idea is not to. Partly because there is some value in intellectual property, and some people tell me, just hold on to it for now, because you never know when a company, you can have some leverage with them, maybe another partnership. Even though we're saying to this person's question that we won't continue, we don't know, right? It's possible we could if someone comes and says, we really need your help here, and they think they can maybe scale it out at the level we're looking for.
Great. Let me check. Yes, sir. Lady across from you. Yes, thank you.
So I'm curious, I actually wanted to do a very similar project, but on age appropriateness rating of YouTube media. So I'm just curious that have you now proven a concept that can be expanded to such things? And it also feels like the winds are changing and there will be interest in doing something like this.
Mm-hmm. Mm-hmm. Age appropriate content. Okay, so let's see. How would we measure that? So you would have people label essentially videos and say that maybe this is 13 and above, 10 and below, find out the categories you want, and then you'll build a classifier to predict that, see how accurate you are with your precision and recall. I think you could do that. YouTube stakeholders were actually part of the meeting that we were in. One of the product managers, she was interested in like sharing this with YouTube. So I think age appropriate actually is right in their alley as well. I think that would be a very interesting project.
I also feel like you've proven a concept that things like harassment, age appropriateness, so on, are going to come on the radar of these companies and become important.
What we talk about in one of our blog posts is that actually the recommendation might be to go with Perspective API, which Lucas's team built. It's more broad than just harassment. And what it can do is, a use case is you could be typing a tweet or on Facebook and so forth. It can actually tell you in real time how toxic your language is, even before you send it. That seems to me more generalizable. So I think that proof of concept, and they have the resources to carry that through, is probably the way to go.
All right. Please join me in thanking Derek. Derek.